Hi, this is Karthik. Today we're going to see about application of context-free grammar in speech recognition. Speech recognition is revolutionizing the way we interact with technology, enabling us to communicate with devices using our natural voice. From virtual assistants like Siri and Alexa to transcription services and dictation software, speech recognition has become an integral part of our daily lives. However, achieving accurate speech recognition poses several challenges, including variations in speech patterns, accents, and background noise. In this presentation, we will explore the role of context free grammar in addressing these challenges and enhancing the performance of speech recognition systems. What is context free grammar? Context free grammar is a formal grammar that describes the syntactic structure of a language using production rules. These rules define how symbols can be combined to generate valid sentences in the language. As context-free grammar consists of terminals which represents the basic elements of the language such as words or punctuation marks and non-terminals. The grammar starts from a designated start symbol and uses production rules to derive valid sentences from it. Components of CFG. It is defined as four tuples VTPS. G is a grammar which consists of a set of production rules. It is used to generate the strings of a language. T is a final set of terminal symbols. It is denoted by the lowercase letters. B is a final set of non-terminal symbols. It is denoted by the capital letters. P is a set of production rules which is used for replacing non-terminal symbols on the left side of the production in a string with other terminals on the right side of the production. S is the start symbol used to derive the string. Speech recognition is a process of converting spoken language into text or commands. It is used in various applications such as virtual assistants, dictation software, and voice control interfaces. Accurate speech recognition is essential for enabling seamless interaction between human and machines. However, achieving accurate recognition involves several steps, including signal processing, feature extraction, acoustic modeling, language modeling, and decoding. Algorithm behind speech recognition. Hidden Markov models, deep learning models, convolutional neural networks, and recurrent neural networks are fundamental algorithms used in speech recognition. These algorithms are trained to recognize patterns in speech signals and map them to textual representations by learning from large amount of data. These models can effectively capture the complex relationships between spoken words and their textual counterparts. Hidden Markov models. Hidden Markov models are statistical models used extensively in speech recognition. In the context of speech recognition, hidden Markov models are used to model the temporal dynamics of speech signals. Hidden Markov models represent the speech signal as a sequence of states, each corresponding to a phenome or subphonetic unit. The transitions between states are governed by probabilities, capturing the likelihood of transitioning from one state to another. Convolutional neural network. Convolutional neural networks are a type of deep learning model commonly used in image processing tasks but they have also been adapted for speech recognition. In the context of speech recognition, CNN are used to extract relevant features from the spectrogram representations of speech signals. Recurrent neural networks. Recurrent neural networks are a type of deep learning model designed to handle sequential data, making them well suited for speech recognition tasks. In contrast to feed forward neural networks, RNN have recurrent connections that allow them to maintain a memory of previous inputs. As I said earlier, the speech recognition involves uh, Signal processing, feature extraction, acoustic modeling, language modeling, and decoding. Now we are going to see what it is. Signal processing. Signal processing is the initial step in the speech recognition process where the raw audio input is pre-processed to enhance its quality and extract relevant information. Feature extraction. Feature extraction is the process of extracting meaningful features from the pre-processed audio signal that can be used to characterize speech. Acoustic modeling. Acoustic modeling involves training statistical models to map acoustic features extracted from the speech signal to phonemes or speech sounds. Language modeling. Language modeling is a process of predicting the most likely sequence of words given the input speech signal. This is based on statistical analysis of the language patterns and probabilities of word sequences occurring in the given context. Decoding. Decoding is the final step in the speech recognition process where the most probable sequence of words is selected based on the acoustic and language models. Application of CFG in speech recognition. Context free grammar is used in speech recognition to improve accuracy and efficiency. By constraining the set of possible interpretations of spoken language, CFG helps to reduce ambiguity and improve recognition performance. CFG rules are can be integrated into speech recognition systems to handle grammar-based constraints and improve the recognition of structured language. The key application of CFG in speech recognition is language modeling, error detection, parsing, voice-over interface design. Language modeling. One of the key applications of CFG in speech recognition is in language modeling. By incorporating the CFG rules into language models, speech recognition systems can better predict the most likely sequence of words given. The inputs given the input speech signal. This helps improve the accuracy of speech recognition by constraining the set of possible interpretations and reducing ambiguity. For example, CFG rules can enforce grammatical constraints such as subject verb agreement, verb tense, word order, thereby guiding the recognition process towards more linguistically plausible interpretations of the input speech. Error detection. Another important application of CFG in speech recognition is error detection. By defining grammatical rules and constraints using CFG, speech recognition systems can identify and flag grammatical errors or inconsistencies in the recognized text. For example, CFG rules can be used to detect syntactic errors such as missing or incorrect verb forms, noun phrase agreement errors, and sentence fragments, allowing the system to provide more accurate and coherent transcriptions. Parsing. CFG is also used in speech recognition for parsing, which involves analyzing the syntactic structure of sentences to determine the grammatical structure and meaning. CFG rules define the hierarchical relationships between different linguistic elements such as nouns, verbs, adjectives, and clauses, allowing speech recognition systems to parse the input speech signal into its constituent parts. For example, CFG based parsers can identify the subject, verb, and object in a sentence as well as the syntactic dependencies between different words, enabling more accurate and detailed transcriptions. Voice user interface design. CFG is essential for designing voice user interfaces in speech recognition systems. By incorporating CFG, by incorporating by incorporating CFG in voice user interfaces, speech interfaces, developers can create more intuitive and user-friendly interfaces that accurately capture user intent and respond appropriately to spoken commands. For example, CFG rules can determine the grammar for voice commands in a virtual assistant, specifying the acceptable syntax and semantic constraints for different types of tasks or actions, such as setting reminders, playing music, or sending messages. CFG based speech recognition systems in real life. Several speech recognition systems utilized CFG to enhance their performance. These systems include voice control interfaces, dictation software, and natural language understanding systems. By incorporating CFG rules into the recognition process, these systems can better handle the complex linguistic structures and improve overall recognition accuracy. One of the example in real time is Amazon Echo, powered by the virtual assistant Alexa. The Echo is a smart speaker developed by Amazon that responds to voice commands and queries from users. Application of COG in the Amazon Echo is Amazon Echo features a voice control interface that allows user to interact with the device using natural language commands. CFG is utilized in the speech recognition process to parse and interpret these commands accurately. By incorporating CFG rules, the Echo can understand and respond to a wide range of voice commands, from simple requests such as playing music or setting alarms to more complex tasks like controlling smart home devices or providing weather updates. Finally, CFG plays a crucial role in speech recognition by constraining the set of possible interpretations of spoken language. Ongoing research and development efforts aim to further improve the accuracy and robustness of speech recognition systems. The integration of CFG based approaches holds promise for advancing the state of the art in speech recognition and enabling more natural and efficient human machine interactions. As we continue to explore the potential of CFG based speech recognition, we are shaping a future where seamless communication between humans and machines become reality. Thank you.